It's really great to be here. A great opportunity to talk about something that I really love, which is democratizing machine learning across the business. And the whole goal of this, of course, is the title of in my talk, Business Value Creation from Data. And so I look forward to sharing my thoughts, and then Jorge from MindsDB sharing more about their product and how that sort of ties in, very, very neatly ties into this whole concept of democratizing machine learning. So again, from my perspective, the real value of machine learning is not just for the data scientists team, the elite team of data scientists and companies doing cool things with data, but having everyone in the organization, in the business, who has access to any kind of digital data, digital information in their work to be able to do value creation from data. And one way you do value creation is basically identifying patterns in data, which is what machine learning is all about. So that's what we're going to discuss in the first half of the webinar today. So sometimes people say, what's all the fuss about, right? We've had business intelligence and databases and even data mining, if you're familiar with that term. We've had those for many years. In fact, 20 plus years, and databases, of course, for 40 or more years. So why is all the fuss right now? Well, I think that the main fuss is basically three main things, which is the ubiquitous data sources. That is, data sources everywhere: sensors, networks, logs, mobile apps, but also more powerful computing so we can do things with data. And so you no longer need to buy a supercomputer. You can actually access one through the cloud. So you can just buy 2 minutes of a supercomputer and then give it back to the cloud. And also the more sophisticated algorithms. So those are technology answers, but the real answer of why this is really so much interest right now and so much business focus on this is really the top line in this chart here, and that is the value that it creates for business. Significant new discoveries and insights that are found in business data can lead to new value. That is, new business opportunities, new market opportunities, a new customer or promotion opportunities, even new products. There's all kinds of new discovery and insight that come from data. And so when you add together these three sort of technology drivers along with the business culture drivers, then yeah, there's a lot of fuss right now. But the big challenge in all of this is to try to democratize those benefits across the whole enterprise. Again, it's not just the database department, it's not just the marketing department, it's not just the IT department. In fact, if you put your data science team in the IT department as a business, you're really making a big mistake, because it's not an IT function, it's a business function. So IT supports every part of the business. Data science and machine learning should be integrated as part of the business. It is the business in some sense. It's all about creating value. So let's talk about that, specifically in the hurdles that prevent us from achieving this, what we're talking about here, this business value creation by democratizing the whole workforce to do pattern discovery from data. So the greatest challenges and hurdles are these, and there's more, but I hear these mentioned quite a lot. And one of those right off the top is technical debt. So what is technical debt? It's when a business invests a lot of money in their IT infrastructure and their technologies. And then when suddenly the business model changes, or the techniques and methodologies in business are changing, which is what AI and machine learning are doing right now. So when this digital transformation takes place as it does now, there's all this extra baggage in the business. There's a tremendous investment in this IT technology and all these technologies that people are using. And it's pretty hard just to say, well, let's just get rid of all this stuff because we have a tremendous business investment here. So the technical debt basically is almost like an asset that is still an asset, and you don't want to get rid of it, but in order to move forward, you got to let it go. So it's that baggage that's dragging you back, holding you back, keeping you down, not making advanced progress. So one way to address technical debt is to try to do the things that we're talking about in terms of machine learning and value creation from data with some existing data technologies. For example, existing databases, and we're going to talk about that. But that technical debt question is a real big one that comes up, and trying to get over the hurdle for the business to make the decision to move forward with this machine learning stuff. Another hurdle and challenge is doubt. A lot of organizations doubt that their people will understand this stuff. They doubt that it's possible for non-mathematicians and non-PhD scientists to understand this stuff. How can the average person in the workforce who doesn't have that degree of mathematical training do this, or some significant degree of coding and programming experience? How can they do it? There's a lot of doubt that people are going to get this and understand it and actually be able to do it. Another hurdle and challenge is fear, specifically in the workforce. People fear they're going to lose their jobs. So it's not just the workers in the sort of the trenches, so to speak, but even sort of the middle management. When they look at AI, they say, "Gee, this AI is going to take over the decision-making function, and the value creation function that my job is doing right now." So people fear losing their jobs, and that sort of builds up some resistance. That even though there might be some push from the top of the business, there's going to be fear. Well, believe it or not, there's actually resistance even from the top of the organization. Because if we're really talking about having AI help with decision making and so forth like that, then maybe even the leaders of the company will fear some loss of leadership capability, or even their job. So fear is a pretty significant human emotion everywhere, and it's definitely true in this case of how these new automated tools and technologies may cause people to lose their jobs. But if you can get over all those things, the technical debt, the doubt, and the fears, there's still a couple other problems, and one of them is friction. So friction is what keeps you from moving very easily, right? So when the hockey players get on the ice, they can skate around very freely, but they couldn't skate on grass or dirt or sand, of course. If you ever try to run as a runner on a sandy beach, it's kind of hard because your feet slip in the sand, right? So friction is what keeps you from moving forward, despite a lot of energy spent. And so people can spend a lot of energy going in and out of their traditional workflows to do this machine learning and data science thing. And that can really sacrifice productivity and can actually add more time to producing a product than otherwise it should. And so this friction has to do with how do we integrate these newfangled technologies, machine learning and data science, AI even. How do we integrate those new things, those new processes within existing workflows without sacrificing productivity? So how do we get over that friction and actually get to that plateau of productivity? But another fear is fragility, and that is how easy it could break. If this were to depend entirely on the data science experts, the elite team who knows machine learning, who knows the math, and knows the coding, if the success of this in your business depends upon that elite team of people, what happens if those people leave? I mean, this is a very hot job market. Data scientists and machine learning engineers are in very high demand. So no matter how great your company is, people are leaving jobs and taking new jobs all over the place. And if that happens to you, is your business fragile? Is your machine learning and data science activity fragile in the sense that it will now break once those experts leave? Who's going to carry the responsibility to do these things if those people leave? Well, democratizing machine learning actually helps to overcome that. Okay, so even though these are challenges to democratizing, once you get democratizing machine learning, you can actually overcome these challenges and hurdles, and we're going to talk about that in the next few minutes here. So I get it. We first of all have to have the talk. And that's what I mean by that is the talk about what is machine learning and data science. The average person might say, I don't think I'll understand this. I don't think it's possible for me to understand this. But you actually can, and I've actually had lots of experience giving public lectures to people who say to themselves, I can never understand this stuff. And by the time they walk out from the lecture, they say, oh, I finally can get this. So I think that is possible. So having the talk has to do with talking, first of all, about terms and terminology that people understand. So one of those things is, what we mean by machine learning? And the very first thing we can mean by machine learning is that it's nothing more than pattern discovery and pattern recognition. Now, it's pattern discovery and pattern recognition done with mathematics and coding. That's true. But in principle, anyone can understand this because even children do pattern recognition and pattern discovery. For example, you ever watch a child playing with their toys? They know how to recognize shapes and colors and different things. But even when they're first born, they recognize the sound of their mother's voice. They recognize when they're hungry. So it's a perfectly normal human trait and characteristic to recognize patterns, to discover patterns. And so all we're really doing is just using mathematics and coding to do exactly what we already do. When we see a particular pattern of traffic in the highway, we know whether to speed up or to slow down or to get off the road or to do something. And so we actually make decisions based upon patterns that we see. So machine learning and AI is nothing more than just recognizing patterns in data through mathematics and coding, and encoding these things in such a way that it empowers decision making in the companies, and not just decisions arbitrarily, but decisions that actually lead to value creation. So pattern exploration has to do with find the patterns that give us the most insights about our customers, the most insights about our market, or the most insights about the productivity or how to increase productivity in our business, the most insights into what are the most likely products to sell in the market. So pattern exploration is about taking those patterns and finding the ones that are most meaningful and value creation for the business. So once you find those patterns, once you've explored and find the things that are most beneficial for value creation, then you do pattern exploitation. Sounds like a scary word, but it's really saying now let's exploit all that we have in our data, all this insight that we've discovered, innovate with it, take action from it, create value from it, sell things, improve customer performance, improve customer satisfaction, include employee performance and employee satisfaction, and so forth. So data to action is nothing more than machine learning, which is mathematics and coding, to do what humans do naturally, which is all these steps here: pattern discovery, recognition, exploration, and exploitation. But it all comes with insights discovery. So let me give you a few examples of insights discovery. So for example, machine learning, which is very simple definition, algorithms that learn from experience, which basically means finding the characteristic patterns in data in order to make the right decision, to take the right action, to do the right thing. So some simple examples. For example, digit detection algorithms. So postal code readers in companies around the world, a tremendous amount of post goes through the mail systems in countries, billions of letters and packages every day. And if it would take a human to examine the postal code and figure out where to ship this letter or this package to, it would be very, very time consuming. And well, this doesn't happen anymore. In fact, it hasn't happened for many, many years, decades even, because postal code readers now use digit detection algorithms. Excuse me. So a digit detection algorithm is identifying the digit that someone wrote, and so they can basically complete a postal code. If the postal code is 1, 2, 3, 4, 5, it has to identify first the 1, then the 2, then the 3, and so forth. So in fact, what it actually is doing is what we call computer vision, because what's written on the envelope or the package is a symbol, right? A number is just a symbol. A 6 or a 7 or a 9 or a 4 is just a symbol. And so the machine has to recognize that this symbol is a number or a letter or something else. And so digit detection is a prime example of where we see machine learning in everyday life, though we don't actually see it. It's done automatically. Another is email spam detection or spam filtering, where basically algorithms that you don't even realize are taking place, you're being used in your email, that it recognizes certain types of patterns like misspelled words or words that suggest that maybe someone's trying to scam you out of some money. So email spam detection is using patterns in previously known examples of spam email, bad email, fraudulent email. So previously known examples of bad email teaches the algorithm how to get the spam filter correct. So both of those things are examples, again, of algorithms that learn from experience. They learn from historical patterns in the data of what makes good email or bad email, what makes a certain digit a certain number or another number. Well, now they're taking this to much more serious applications. Of course, those are serious, but much more serious. For example, cancer detection. So cancer detection, AI algorithms and machine learning algorithms look at patterns in medical images to determine if there's a cancer. So what kind of patterns? Well, it could be something as simple as, does it have a smooth edge or a rough edge? So if you have a tumor in your body versus just having a scar from an accident, the fuzziness of the issue of the tissue, maybe the shades of gray in the tissue, that is it smooth or is it high texture? That is it sort of like a very bumpy texture or very smooth texture? These types of things tell you about what type of object that is. Is it a cancer, or is it a scar, or is it some kind of bruise, or just some kind of inflammation? So it learns from previous data, that is, it learns from experience what a cancer is in order to get it right. So all these things, like I say at the top of the page, machine learning are algorithms that learn from experience, that is, past examples of cancers or digits or spam email. It learns these characteristic patterns to get things right, to get the mail to the right place, to get the spam to the right place, to get the cancer patient to the diagnosis and then to the doctor's treatment as fast as possible. And there's many other examples. I mean, literally thousands, if not millions of examples now in business and in the world where this is happening. And we don't have all year to talk about this, but I'll just mention three more briefly. Credit card fraud alerts, chatbots, which maybe some of you use when you talk to your chatbot to order things or to ask questions just by talking to the chatbot, or even call centers. Now, when you customer call centers, there's a chatbot that frequently helps in the first round of questioning with the customer to find out what it is they need to direct their call to the right person. And also online product recommendations. So I'm sure we've all seen those online product recommendations that recommend products to us. Okay, so when I talk about patterns in data, that all is well and good. Now, what does that actually mean? I mean, it's okay, fine. We discover patterns, we recognize patterns, we make decisions from patterns. What exactly am I talking about? Well, first of all, pattern recognition comes in sort of four broad categories, and this is not all there is, but there's sort of four broad categories of pattern discovery. And now we're getting very much closer to the mathematics of machine learning without the mathematics, right? We're not talking about the mathematics. We're talking about things that we can all understand, which is why democratization is not as difficult as it might sound when you try to bring machine learning to business workers who aren't familiar with that math and coding. I'm pretty sure they can understand some of this terminology we're talking today. So what are these four general categories of pattern discovery? Well, one category is group discovery or class discovery. So if you look at that diagram on the upper left there's sort of three main data clouds 1, 2, and 3. And this is a made-up data set with three parameters, parameter P1, P2, and P3. And you see these data clouds. Those are groups. Those are clusters. Those are populations. Those are segments of the population. So class discovery is nothing more than just finding groups of things. You can group, like even children, they group their toys by color, by shape, by size. They even can group their toys by function, right? You play with certain toys inside the house or you play certain toys outside the house. You can, for example, build a castle with blocks, but you can't play ball with a block. Just like you can play ball with a sphere, a ball, but not with blocks. So knowing the functions and colors and shapes and sizes, so to speak, of your customers, of your products, of your market, you can start finding these different segments and start marketing to different segments or even creating new products for those segments. So class discovery, group discovery, population, subpopulation discovery is part of pattern discovery in machine learning. That's number one. Number two is correlation discovery. When X correlates with Y, you found a trend in the data. From that trend, you can predict, for example, given a particular time of year or a particular price point on a product, what will sell, how much will sell, what the price it will sell for. And so finding correlations in different patterns leads us to those things like those predictive analytics models that people love to talk about in business. What is predictive analytics? It's just basically finding a correlation that some particular input leads to a particular output. And that's what X versus Y is all about. But that's just not only predictive, it's also prescriptive. That if you realize that if X and Y are correlated, and if X is some kind of a causal variable, that is something you have control over. For example, a discount on a marketing campaign. Or maybe if you're in a machine or manufacturing plant, you set the temperature, the operating temperature, or the operating speed of the equipment, and that can affect its efficiency. So if you realize that some of these variables are causal variables, you can move, that is, if you control that X, you can move that Y variable, the output variable, into the direction you want. If you want to increase productivity or decrease losses or decrease risk, or employ customer satisfaction, increase customer satisfaction, or decrease customer attrition. So once you find what those causal variables are in a trend or a correlation, now you have what we call prescriptive power discovery. So prescriptive power discovery is about optimizing outcomes for the business. Wow, if you can get all your employees to not only discover new segments of the population, up number one there, but actually predicting outcomes and then optimizing outcomes, I think you got a pretty powerful workforce doing those things. But there's still a little bit more in pattern discovery that humans are really good at. And number three is one that probably every human is really good at, and that's anomaly detection or outlier detection. I think that's a kind of a negative way to say it. So I just prefer to say surprise discovery. What's the surprising, interesting, unexpected thing in your data? So that's surprise discovery. So everyone can recognize the thing that's different, right? If you walk in the room and there's a bowl of green apples and there's one red apple, you immediately notice the red apple. If you have a bowl of fruit and there's all apples but one banana, anyone can recognize that, right? So surprise or novelty discovery is finding the customer that's different, or the product that's different, or the behavior that's different. So this is especially important in for example, cybersecurity. Do we see anomalous behaviors, unusual, unexpected behaviors of people on our network? It's also very beneficial in the business world in terms of anomaly in the positive sense, which again I call surprise discovery. That is, you might discover that there's a new market, a new customer interest in a new type of product. And so maybe your company can start developing that kind of product when you realize that there's a new interest in the consumer world for a particular type of product. That's a surprising behavior in data. So those are all great examples. The fourth one is a little bit different from the others. It requires its own little diagram in the bottom left. If you haven't noticed, the first three things I mentioned are all illustrated in the little diagram in the upper left. We got groups and discoveries. We got strong correlations. For example, Data Cloud 2, we see some strong correlations between parameters. And we even see these data points that are scattered around. They're outliers, right? So, but what about association discovery? That's when we find links and connections between things. For example, people who bought this product also bought that product. That's an example of a link discovery. Lots of money can be made through association and link discovery in business. It's finding the connections that otherwise aren't connected. There's a historical story in the data mining literature that said long ago, they discovered when they analyzed customer purchase logs that when men go to the store to buy diapers, they tend to buy beer at the same time. Okay, so this beer and diapers example was a fine example of a surprising link discovery, a link between two types of products being purchased by customers. And so these are finding the unusual and interesting links in data. Now, I'll mention one final example before moving on, and that's fraud detection. Specifically, I'll give you an example of money laundering, a type of fraud. So money laundering is when if person A were to transfer money or give money to person C, that would be flagged as a fraudulent transaction, probably because there's some police or law enforcement database somewhere that says these two people should never be exchanging money with one another. Okay, so a normal link discovery or inquiry into that database would find no connection between A and C. But if they go through an intermediary, that is, A transfers money to B and then B to C, maybe all those transactions are okay. A to B doesn't flag any particular fraudulent activity. B to C does not flag fraudulent activity. So A transfers to C through an intermediary. That's an example of a graph model or a network analysis model. So, for example, that blue character in my little chart there might be transferring between the green dots and the big yellow dot. Okay, so this is not always negative, and money laundering is an example of a negative thing where the intermediate node in the network there is the money launderer. But marketing attribution is a good example where there's an intermediary that helps to boost your marketing campaigns, and that could be someone who's like a social influencer. Okay, the social influencer stands in the middle between your brand and the customers out there who are buying your product. So these are all examples of pattern discovery we can do with data. So if you look at actual business applications of machine learning and data science, and you can talk with all your employees about this, not just the elite data scientists, all your employees, you can start to see all the things that are being used where analytics and data science, machine learning, data analytics are being used. But I put a red box. So the red box is around some of these items. I put this in the chart here. So you can find this chart on the website shown below. But the red boxes I put on this chart. And why did I do that? Because all the ones that are in red are in some sense predictive analytics. That is, they're predictive models. And I think you could ask any business leader, and they would think probably the most powerful application in their business is predictive analytics. Even though I would argue with them and say, well, prescriptive is even better, because not only can you predict an outcome, but you can find out what to do to optimize that outcome. But even so, predictive analytics can make you a real data science hero in your business if you can do some of these predictive things, which I think every employee is now capable of doing. So how does it happen? How do we do this? How do we democratize all the stuff we just talked about? Well, Jorge is going to come up after me in just a couple minutes now and talk about the MindsDB product, which actually does machine learning in the database. And so literally you can do SQL queries to learn models. Remember what I said, machine learning are algorithms that learn from experience, learn the patterns in data. So you can actually, with an SQL query, learn the model, learn what the pattern is, whether it's a group or a cluster or a correlation or an outlier or an association or some kind of a link that you can build a predictive model from. Then you can actually run the predictive model with another SQL query, just predict an outcome given particular customer data, particular product data, particular market data, whatever you have. You can build a predictive model. And if your boss says, well, how do you get to that prediction? What is the data that tells you that this is the right prediction? Then you can actually ask through an SQL query for the model to explain itself. All right. Isn't that wonderful? It's like having a data scientist in the box. Explain yourself. How did you get this? And so you can do all this in the normal database workflow of your normal database workers. And pretty much most business workers today, certainly business workers who work with any kind of data, are probably extremely familiar with SQL. So this is directly embedded in their everyday workflow without coming out of their workflow to do this. And it does things that they are very natural at doing, as we just described: pattern exploration, pattern discovery, pattern exploitation, and so forth. So we basically conquered all of our fears and all of our technical debt problems, all of our doubt, all the friction and fragility. We basically conquered all those challenges with this democratization by putting the machine learning in the database. Okay, so basically we conquered the technical debt problem because we don't need to buy new data technologies. We can do this in the existing databases. Our doubt is conquered that all business users can do this because, wait a minute, all business users who work with data are probably already working with databases. And so they can train and use machine learning models with ease using this. And the fear is conquered because now the employees say, hey, I already know how to use databases, therefore I can become quite the predictive analytics guru for my company. I can do all kinds of cool stuff because I already know databases. So it removes a lot of fear also. And because it's done within existing workflows, that is within existing database tools, that friction is conquered. That is, the worker doesn't have to leave their normal workflow, go build some model somewhere and bring it all back to the database and try to figure out how to integrate all that. It's already there. The workflow is not disrupted. In fact, performance and productivity is greatly enhanced because of the seamless process that machine learning and the database gives you. And then finally, that concern about fragility, that is what will happen if all of our elite teams of specialists and data scientists leave the business. Are we going to fail? Is our business going to have to stop doing analytics if we lose those people? No, of course not, because we've just empowered all your people to do this. So the responsibility for success of these analytics and data science and machine learning tasks now fall to everyone. So everyone wins in the business. So machine learning in the database really changes everything. Or as I like to say, democratized machine learning has never been so democratized as it has now. So that's my presentation. Jorge is going to take over now, and we will take some questions at the end. But thank you very much for listening to me. I'm not leaving. I'm just going to let Jorge take over.
Thank you, Kirk. That was fantastic. We're going to take it from the idea of the hurdles and the challenges that people have when they try to do machine learning, and kind of building up on that last part that Kirk was kind of describing, where if you do it in the database, you're essentially removing many of the hurdles. And why we're doing this as well as an open source project essentially is because we want to adhere to that vision of really democratizing it, making it available to as many people as possible, and making it available to as many databases as possible as well. So we decided to summarize the concept of doing it in the database through kind of like this name called AI tables, and we're going to describe the journey there, what you can get out of MindsDB right now, the intuitions behind the way that we build MindsDB, and what's coming as well that is purely driven by feedback from our community. And then at the end, to invite you to join us in the journey of really democratizing machine learning, and for you to try it if you see the need. So the first thing is the intuition. when you do machine learning at the application layer, you're dissociating the machine learning building block from its main asset, which is data. And yes, a lot of machine learning problems have data that is not in the databases. But for many industries and many companies, they've been collecting data for a long time. And the machine learning pipelines are dissociated from the databases in itself. And then you have to go through many processes to get that data into the machine learning model. And then even when you're doing predictions, depending on your problem, you have to make this dance between the database, the requests that you're making, and kind of make transformations all over again, return that information to the user. If that is an application that you're going to have potentially to mix that data back in the database. So if you start seeing machine learning models and data models, you start to see that they are so intertwined that perhaps they belong in the same place. And here are some intuitions. Like when you have a data model, you have the schema that defines the data model. And when you have a machine learning model, you have the graph that defines the machine learning model itself. That doesn't contain any particular data per se, but it defines how this model behaves and how it correlates to like the different variables in it. Now, when you have in the data model part, you have data that fits the schema, and on the machine learning world, you have data that is what the model is trying to fit to, and then those are the parameters that at the end will define how the graph behaves. And this should not be static, just like data in a database is not static as well. Like as data changes, the idea is that your model adjusts to understand how the distribution of the data changes as well. So given that the data changes constantly, machine learning models should change as well and evolve as data does. And you should be able to manage this with similar kind of intuitions and kind of workflows that you do for data without having to reinvent the wheel. So it makes a lot of sense to start thinking of machine learning not as an application layer problem, but as a data layer problem. And the intuitions behind it will make sense a little bit more later in the presentation. But think of this, like most of the world's information in companies today lives in either structured or semi-structured data. There is a lot of unstructured data, but a lot of the information that companies have today is already structured or semi-structured data. When I say a lot, it's more than 60%. Now, there is 1.1 million companies in the world that directly use a database on a day-to-day basis for archiving the information that is contained within their business. And by enabling machine learning in those databases, you're all of a sudden enabling 60% of the world's semi and structured data to be used in a more native way to apply machine learning. So right now, MindsDB supports ClickHouse, MariaDB, Postgres, MySQL, SQL Server, MongoDB. And again, we will continue to expand this to as many databases as possible with the intuition that if we do it at the database, then we can really democratize it by reducing each of the hurdles that Kirk was mentioning. Now, to summarize this, the dance that people do today when they see machine learning in the application layer looks as follows. You have like the application, you have the database, and then you have to do this back and forth between application, database, machine learning, all the orchestration, all the things that you need to do, reinvent the wheel many times to kind of maintain a machine learning model architecture. But if you keep it within the data scope, then the flow is the same that people have today. You have like applications, you have the database, and then you're retrieving data, either if this data is existing data or predictive data. So data that is being generated on the data, based on the data you have. Now, a simple way to describe this is imagine if you have a table. And of course, tables and databases are way more complex than this. But for the sake of this example, imagine that you have an income and debt table. And if you were to plot this in an XY axis, you will see that each point will be reflected there. Now, each row that you have will signify a point. Now, traditionally in a database, you can query for things that actually have an exact match. Like say, for instance, you would like to predict where the income is 80,000, and if there's an exact match, you get a response. But if you move just a little bit from that where condition, and you don't have an exact match, then you get a null, even though you have data that is very close by. Now, you can think of a machine learning model as a surface or a hyperplane that fits these data points, and that's what a machine learning model will try to do. Like, what will be like the one that fits all those data points that I have in my database? But it would be really cool if you could query that line the same way that you query a table. So for example, if you could select from the model where income is 90,000, even though you don't have that exact data in the database, now that you're querying the model, you can get an estimate of what that can be. And this is the intuition that we built MindsDB upon. Being able to not only query tables as you do, but also to query models that are built from the data that you have in your database. And again, understanding, of course, that your tables can be way more complex than this income debt example. So for instance, let's imagine that you have a database that has rental prices, and all of what you have is 2 columns. Again, this is a very simple table nonetheless, but you have description of your properties, say for instance, information that you're putting up from Craigslist, and you have the price of the properties. Now, making a query that is an exact match, given a description, will be really hard, because you will have to kind of like essentially know exactly what is the text that you have. But what if you can send something that is very similar and still get a prediction for the price? So as you can see, even though tables may be like large or small, the complexities that you can kind of like tap into are limitless. And the ability to build models, even if this data is somehow complex, is what MindsDB tries to portray for you. So right now, MindsDB allows you to create models from any table that you have in a database that we support, if your table contains either text, bag of words, images, numbers, categories, and you can deal with these problems either like taking just one row into account or taking historical data as treated as a time series problem. Now, by doing this, you're merging the database and the machine learning world, and you can allow the applications to consume machine learning capabilities the same way that they consume data. And really, that's the invitation that we have here. Yes, this doesn't apply for problems where the data is not in the database, but again, so many companies and so many people use databases today that it's a worthwhile problem to solve as we do. So the way that it works is you have a MindsDB server, and you can publish models to any of the databases that you have as tables. Again, you can learn and train these models from the database as well, and then you can query them straight from the databases that you have. We have done this already for like about a year, and by doing this, we've kind of understood a few of the things that can improve the way that we do things even further. And even though right now the invitation is that you guys go try MindsDB and try the solution that we have for the databases that we support, we want to show you what's coming for like the next coming months. And this is what we call MindsDB 3.0. So we understand now that people can treat machine learning as something that is within the data layer. The SQL intuitions that people have for querying data can be enhanced a little bit from the scope of MindsDB, without having to make that learning curve any different from what they have already learned. And here are a few of the things. When you create a model, even though right now in MindsDB you can create a model by inserting into a magic table called predictors that will generate a model, such as what we do here, really creating a model is very similar to creating a table. And all of what you're doing, creating a table from another table, which is something that has been supported for a long time in most SQL servers. And what we do here is to kind of borrow a lot of the elements for when you create a table, but now you create a model. So create a model, whatever you want to create this model from, and what do you want to predict. And of course, to be able to pass other parameters if you may. So another thing that we've learned here is there are a lot of teams that have the capabilities to build machine learning models on their own. Yet the hurdle of moving it into production so that these models can be consumed by non-machine learning engineers, but more like the data scientists and people that touch data on a day-to-day basis, is a worthwhile effort. So being able to offer the capacity for all of those that have models that were built like on scikit-learn and infrastructure that is different from the infrastructure that MindsDB provides for you, to be able to somehow publish those as tables, the same way that you will publish another machine learning model that is built with MindsDB, but then these models can be as custom as you decide. So there are a lot of frameworks that we kind of provide as well in 3.0 for people to wrap them and expose them in a kind of like standard RESTful API. And then if that is the case, then they can be consumed from any database and being published to the databases that we support. The other thing that we understood is when you have a model, you have a model that you can query with like either one data point at a time, or you can pass a query that you want to predict from. But there is this concept of, if I have a stream of data, I would like to decorate the stream of data with a specific prediction. So say, for instance, if you have like a lot of new rows in that first example where you have, for each new customer, you have like their income and debt, and you would like to predict what would be the debt for those that you don't have the actual value, the ability to join a model with a table, and therefore decorate that stream of data with a specific model is something that we'll support with a very similar syntax that when you do, since you don't really have to pass like on which columns you're joining, it will be just simply to tell that you're joining these two models and tables, and it will try to like figure out what's the best way to do it. And in that sense, you can actually now start querying the streams of data that have been decorated. And for that perspective, just kind of like extrapolate that knowledge into all of the elements that are already existing in your database, such as views, and being able to kind of plug it into the same pipelines that you already have. The other thing that we've done quite well over the past year is understanding that a lot of the data that exists in databases today is transactional. And by being transactional, a lot of the intuitions that people have is that you don't have to make crazy transformations. And by that I mean transformations, you don't have to bring the historical data that you have within that same table to make predictions based on one single row. You will like to take into account information that you have on the past. So a lot of the big improvements that MindsDB has done over the last year that we've been doing this, especially with the integrations that we've done with ClickHouse, is understanding that the more complicated your data problem is, even if you have machine learning capabilities, it is hard to build them. So time series is one of those problems that even if you're a very, very well skilled machine learning engineer, doing time series problems involves so many mechanics that if we can abstract many of those so that you can focus on the meat of it, then the value of AutoML all of a sudden is tenfold than what it is by default. So time series is one of those things that MindsDB is learning to do really, really well. And we invite you to try it if your data is transactional, it has like a time component, and even if it has like thousands and thousands of group bys, MindsDB can really be kind of an optimal solution for this. So when I say by group by is, you may have not just one single time series problem, you may have many different small time series problems within a table. Say, for instance, if you want to predict what will be the price that you're selling a specific asset, that can change over time, but you have in that specific asset table, you have many different symbols. Like say, for instance, if you want to predict stock, and you have the prices over time as stock changes, but therefore you have as many models as the symbols you have. Like you may have like Tesla, you may have Google, you may have so many different assets here. And MindsDB is really good at, with one single statement, learn how to build models for all of those many time series that you have there. So the last thing that we are understanding right now is that this capacity that we brought into MindsDB of being able to publish things into the database allows you to kind of like create different transformations, aggregations that may come from different data sources and mix them together to train a model, but also that capacity of publishing information that may come either from the machine learning model or even data sources that are not your native data source, and publish them to the data source that you want to use. So the ability to publish things to other databases is something that we're enabling for other different types of problems. And again, right now, the ones that we support are MySQL, MariaDB, Postgres, ClickHouse, Microsoft SQL Server, and Mongo. So the invitation that we have right now for you is to go try MindsDB. You can find us on GitHub, github.com/MindsDB. Try it, give us some feedback, get involved. If you star us, we'll make sure to add you into our mailing list if you want. Join our community, and make sure that if your information is in a database, that you don't miss out this opportunity, kind of like bringing all the machine learning capabilities that are available today in a seamless manner. Kirk, thank you as well. I think that your insights are very, very valuable every time we've spoken. So looking forward to see what we do next with your help.
Yeah, I look forward to future things from you. So thank you.